So yesterday we discussed one important point that in an electric field, the time taken by the body in electric field, the time taken by the body depends on the mass or not. Yes, it is directly proportional. Heavier the particle, time taken will be more. But in gravity, if you remember in vacuum, if you drop a heavy object and a lighter object, time taken by both of them in gravity inside the vacuum is same. So it is independent of mass. That is a major difference between the time taken in electric field and time taken in gravity, which is called gravitational field also. Remember that point? So let's solve few more questions on electric field. So today's session will have few numericals on electric field. Then we will discuss electric field lines. Then we will discuss dipole, and then we will discuss electric field due to a dipole on its axis, and then on a plane which is perpendicular. And last May, if we have time, we will discuss torque also. And this much is your tomorrow's syllabus. Whatever we finish by today. Write down the question. So the first question of the class. So we have 2 point charges. 2 point charges plus 16 microcoulomb and minus 9 microcoulomb are placed 8 centimeter apart in air. So determine the position of the point at which resultant electric field is zero. Resultant electric field is zero. Determine the position of the point at which resultant electric field is zero. So this kind of question we have solved yesterday also. So 16 microcoulomb minus 9 microcoulomb. These are the two charges. The distance between them is 8 centimeters. So centimeters. So 8 into 10 to the power minus 2 meters. This is the distance. So let us assume that. Let us assume the point is here. Let us assume, if you remember what we discussed, the neutral point, all of you listen to me carefully, see on the board. Let us discuss the concept here before we start solving. Calculation, so you all can understand what is the concept here. We discussed if we find the neutral point should be always closer to the charge of smaller magnitude. Which one has smaller magnitude? 9. So neutral point should be closer to the charge of smaller magnitude. This is the concept. Now let's use the direction of electric field. Positive charge, electric field due to a positive charge goes away from it. Away. So at point P, due to this, what will be the direction of electric field? This one. So if I say A, so EA will be towards right. For negative charge, what is the direction of electric field? Towards it or away from it? Towards. So EB will be also in this direction. So both of them are in same direction. Is it possible for the electric field to be zero here? No. So this was again asked as a question that if two charges are of same sign, then you can get the neutral point on the line joining them. If the charge is of opposite sign, you cannot get the neutral point on the line joining them. Is it clear? Make a note of this concept. That's what I was trying to explain you. That numerical, so you can solve, but what is the insight you will get from that? That is important here. The charges are of different sign, and you can see that P cannot be neutral point. It is impossible. Both of them are in same direction. So neutral point will be outside the line. It cannot be on the line joining them. In this case, it has to be outside the line. Outside means either this side or this side. Noted? Any problem? Don't blindly remember that. I hope that explanation is clear. Why the neutral point cannot be on the line joining them when the charges are of opposite sign. If I make both of them as negative, if I make both of them as negative, then EA will be towards this direction, towards the negative charge, and EB will be towards this negative. So both of them will be in the opposite direction, means neutral point can exist. But when the charge are of different sign, there is no possibility. Now the second question comes, sir, the neutral point cannot be on the line joining them. It means neutral point should be outside AB, either left or right. Either neutral point can be here, I am marking that as N, neutral point, or neutral point can be here, right? Without solving, can you guys tell me which should be the answer? Left wala or right? Left. You guys understood the problem, what I asked? The two possibilities will be there outside, because on the line, though it is impossible. Left side or right side, right? Anyone for left? There's nothing to solve. See, when you solve, that's what I'm telling you. When you solve, you will get the answer. But sometimes these kind of question comes as an assertion reason. As a four options will be given, and they will not give you any data. They will say one positive, one negative, and the magnitude ka difference. How will you calculate? How will you tell the things without doing calculation? So that's what these type of questions, you need to bring the information and remember that. So correct, Ritvik, your answer is correct. Neutral point should be close to this one. That's not we discussed, right? Neutral point should be close to charge of smaller magnitude. If I take this, so it is closer to smaller magnitude, right? If I take this, it is closer to smaller or bigger magnitude? Bigger. What should be the answer? This one. Now calculate and check whether I am telling whatever is the answer is right or wrong. Check it. So this should be the right answer. Now I am assuming that P is a neutral point. I am assuming. So what is the distance? X. Check it. What will be this distance? This will be how much? 0.08, right? So this will be 0.08 minus x. So according to the question, the electric field at point P should be 0. It means both the electric field should be equal and opposite. I know that it is not. It is not. Okay? But I am assuming it. So I will say that EA equals to EB. So EA will be equal to how much? KQ by R square. So KQ, Q is 16 into 10 to the power minus 6 by R square x. K 9 into 10 to the power minus 6 by 0.08 minus x square. K cancel, 10 to the power minus 6, 10 to the power minus 6, cross multiply, 16 into 0.08 minus x whole square equal to x square. Take the square root on both the sides. So plus minus 4 0.08 minus x equals to x. Do the calculation. So if I take plus sign, 0.32 minus 4x. So this will be how much? 5x equals to 0.32. So x is equal to 0.32 by 5. So this is meter or centimeter? Meter. If I convert it to centimeter, what will be the answer? 32 by 5. So 32 by 5 lies on the line or outside the line? Outside. It is 8 centimeter. 32 by 5 will be between them, right? Is it possible? We discussed that it is not possible. So this answer will be rejected. Is it clear? Why is it getting rejected? Because we just now explained that both the electric field is in the same direction. So we cannot have a neutral point here. Now take negative sign. So minus 0.32 minus minus plus. So what do you get? Minus 0.32 equal to minus 3x. Solve it. Check what is the value come.
So where did the 9 go in the above equation?
What happened? I missed 9.
Yes, sir.
Which 9?
So
So this
9
one.
into 10 to the minus 6.
But I didn't write. Do the calculation again. I didn't write 9 only. This 9 I didn't write. The whole calculation. Okay, now you guys understood, right? Do the calculation on your own. And you should have told in the starting now when you noticed. Why did you wait for me? Take, chalo. So take the square root. So this will be how much? 3. Now do for the plus sign. So 0.32 minus 4x equal to 3x. So this will be how much? 0.32 by 7. Or you can say x will be 32 by 7 centimeter. Now, second, minus 0.32 minus minus plus 4x equals to 3x. So x will be equal to how much? 0.32 meters. X will be equal to how many centimeters? 32 centimeters. Now tell me that which point is on the line and which point is outside the line. First one is on the line. Second one is outside.
Outside the line.
So this answer will be rejected. And when you will reject this in a subjective question, if you reject without writing the reason, out of 4 or 3 marks directly, they will cut half of 1 marks. So make sure that you write down the reason here. It cannot be the answer because at a point on the line joining both the charges, electric field is in the same direction. So we cannot get a neutral point. So neutral point has to be outside. It has to be close to smaller charge. So that's why neutral point should be on the right side. This much explanation you have to write. Now, 32. This much is how much? 8 centimeter. So this will be how much? 24. So where is the neutral point from this? 24 centimeter on the right. Is it correct? Yes. Akka? Is it correct or wrong? Correct. X is what? What did we assume X as? Distance of this charge from the neutral point. Okay. So here, this much will be how much? X. Right? This much will be X. This much is 8. So 32 minus 8 is 24. So don't get confused. See, the calculation what I did is with respect to X such that the neutral point is here. So corresponding to this diagram, what is the value? 32 by 7, which is not possible. If you're getting confused, you can draw one more diagram where you show that x is from A to this neutral point. So that x is how much? 30. So this looks as a simple question, but it's a very conceptual question which teaches you a lot of things. So mark this as important. A assertion reason can be asked from this. A case study can be asked from this. A subjective question can be asked from this. Any questions, anyone? Copying? I'm scrolling up. Click. Next problem. We have three charges. This point, I will mark the points. Let me draw the figure, then you copy. This point is C, and then we have a point A here. We have a charge of 10 to the power minus 8 coulomb at this point, and a charge of minus of 10 to the power minus 8 coulomb at this point. So if you guys see, the figure is we have two equal and opposite charges, 10 to the power minus 8 minus of 10 to the power minus 8. A is the midpoint of this line. A is the midpoint of this line. So this distance is 0.05 meter. This distance is also 0.05 meter. So you need to find the electric field at point A, point B, and point C. I'm repeating the question. We have two equal and opposite charges kept at this point and this point. You need to find the net electric field due to these two charges at A, at B, and at C. This is the question. You need to find the net electric field at point A, B, and C. We need to find the net electric field at point A, B, and C. हमारे नहीं है, खेल नहीं है। ठीक है, रोहित तो भाई, मानस तो भाई, एक क्लास में बात। नाम भी नहीं पता उसका। हाँ, तो मैथ्स का पेपर वहां पे रखा था, मैं किसको दिया? वहीं पे रखा। दोस्त में सारा नाम लिखा है। Just keep it on the table, I will take. तो कौन बच्चा था सूरज जो लास्ट तक लिख रहा था? नहीं था ना? तो याद है जो लास्ट में कॉपी सबमिट किया था, यही बच्चा था ना? प्रणव यही था। हाँ, तो हाँ। Keep all the papers here itself. Those question papers will keep you. That's getting the answer for A. Anyone got the answer for point A? Zero.
Sir, is it 7,200?
Well, in terms of decimal, one decimal places.
It's 7.2 into
In
10 to the power of 3.
7.2 into 10 to the power 4. But answer is 7.2 into 10 to the power 4. If you're getting 0, means you have taken wrong direction. Okay. How of you got the answer? A, yeah, A to it's very straightforward. Anyone else who is getting some answer at point A? This is the last question. This is the last question of electric field. And I'm seeing that most of the class is blank here. Point A, see on the board. Due to this charge, this is positive or negative? So electric field will go away. This is negative. Due to this, electric field will go towards it. So both the electric fields are in same direction or different? It cannot be zero. So electric field at A, I will mark this as P and Q. Due to EP, EQ, both will be added because they are in the same direction. And if you notice carefully, their magnitude will be same because charge ka magnitude is same. Distance from point A is also same. Don't calculate them separately. Calculate one, multiply by two. Use common sense in the exam. You will save a lot of time. So I will write 2 times of KQ. So Q is 10 to the power minus 8 by R square. R is 0.05 ka whole square. So 2 into K is 9 into 10 to the power 9. This will be what? 25 into 10 to the power how much? Minus 4. Let's solve it. So 2 nines are 18. 18 by 25. And this will be how much? 10 to the power. So this will be 1 and this will be so 10 to the power 5, right? Correct. Now let's divide it. 18 by 25. So 25 into 7 is 175. 50, 7.2. I'm getting 10 to the power 5.
Sir, I think it's 10 to the power
That's a
4.
0.7. Ah, good. 0.7. 0.7. So 7.2 into 10 to the power 4. What is the unit for electric field? Newton per coulomb. But pen. Negative, so direction is already taken care of. Once you decide the direction, how did you decide the direction? By using what? Sign. So once you consider the direction, then you don't have to put negative again. Are you getting it? Funda is very simple. Once you consider the direction was considered by using positive or negative charge. So once you consider the direction, it means you have considered the sign. Don't take sign again. I'm understanding you are trying to tell that why we are not using negative sign for this. So the purpose of negative was to different direction, to give you direction. Direction I have already considered that both of them are in same. So don't use negative again. So this confusion may happen with most of you. Maybe not now, maybe later. That why not negative for this? I'm repeating again. The negative charge is there to just tell you that what is the direction. So once you have taken into account that what is the direction, don't write negative again. So for vector quantities, whenever negative sign is there in the charge, that will give you the direction. And once direction is taken, don't put minus again. So A is done. Now let's solve for B. Any answer for B? 9 into 10 to the power 3. Okay, let's check whether it is correct or not. So 9 into 10 to the power 3. So at B, what will be the direction of electric field due to this positive charge? Away. Because of positive charge, field lines always move away. So because of this, field lines will be away. So this is because of EP. Now, because of negative at point B, because of negative, it moves towards the negative. Towards the negative. So towards the negative means this. So this will be electric field due to what? Q. So both of them are in the same direction or opposite? Opposite. So you add or subtract? Subtract. Anyone in the class who is having doubt with the direction? Direction is the most important thing in electric field. So whenever you have doubt, clarify at that instant. Don't wait for me to complete. Now, second thing, whose magnitude will be more due to this charge or this charge, which is closer? Because electric field is inversely proportional to the distance. So the charge which will be closer will have higher magnitude. So electric field at point B will be what? EP plus EQ or minus? Minus. So calculation I'm not going to do, you have to do. So K, Q is same. The distance is 0.05 ka whole square. Charge is same. Distance is different. What is the distance? 0.15. So what can we take common? KQ. Anything else? 0.05 ka whole square. Yes? 0.05 ka whole square. So what will be left in the bracket? 1 minus. If you take 0.05 ka whole square common, what will be left here? 3 square. Because what is 0.15? 0.05 into 3. So what will be left here? 1 by 3 ka whole square. Correct? This thing, have you calculated? Yes. See here, that's what I'm telling that when you do the calculation smartly, you save a lot of time. So this one is 2 times of this. This value is 2 times of this. So this much will be how much? 3.6 into 10 to the power 4. This value will be 3.6 into 10 to the power 4. And this much will be how much? 1 minus 1 by 9, 8 by 9. So 9 fours are 36. So 8 fours are, so 3.2 into 10 to the power 4. That is the answer I am getting.
Sir, I got 3.15, sir.
That much is fine. No problem. Are clear? Did you see that I didn't do any calculation? Without calculations, just we use the previous thing. Okay. C is 0. It will not be 0. We'll form a parallelogram. Achha, theek hai. Tell me that any problem in the first two parts? Everyone is clear? All of you understood why did I write this 3.6? Because this is two times of this. So I just halved it and wrote it here. Can we do that in the board exam? Yes, you can. There is nothing wrong. You can directly write 3.6. Just mention that this is two times. So this becomes half. Okay, let's discuss the last part. Any answer for the last part? You guys are not revised? I made a tough paper for tomorrow. I'm telling now itself. But it is exactly same as the thing which you have done in the notes. If you revise the notes and practice, you will score full in tomorrow's exam. Full. But I'm seeing that you guys are struggling with the basics. I just thought that A and B to all of you will solve because it is just formula based. I thought C may you will get stuck. A and B was just straight line. Acha, theek hai. Should I erase this? Copy it? At least draw the parallelogram, na? At least draw the parallelogram at C because there will be two vectors. Complete the parallelogram. This is the first time you guys are solving this, so don't worry about your answer, whether it will be right or wrong. At least try. If you're trying also, it's more than enough. Chalo, let's do the C ka thing. So I need to find what is the net electric field at point C. So this positive charge will say that boss, at point C, electric field line will go like this. Why? Because positive charge sends the electric field away from it. Or we use the word that electric field lines diverge from the positive charge, go away. For negative charge, it converge, come towards it. So for positive charge, electric field lines will go away. So what will be the direction? For negative charge, field lines will converge, come towards it. Electric field lines will be like this. Remember seeing this figure? In fourth question, we did it. In the fourth question, we have already done this. So what will be the resultant? Parallelogram.
So
So
there's a
this will
9
be
into 10 to the power 3.
9 into 10 to the power 3. Okay, noted. I got one answer. Let's see if it is correct or not. Anyone who gets the answer, let me know. So is the diagram clear? So this is EP, this is EQ, and this is the resultant. Okay. So if you see that, what type of triangle is this? Equilateral. So this angle will be how much? This angle will be how much? If you remember the basics, what I told, when we have two equal vectors, when we have two equal vectors having angle 120, the resultant will be equal to one of the vector itself. Yesterday we did it. F and F having 120 degree. What was the resultant? F only. So if you see, the magnitude of EP and EQ are same or different? Same. Because charge is same. Distance is same. Correct? So EP and EQ ka magnitude is same. So I will directly write, but you will not write in your school exam. Okay, you have to show the step. You will write ER equal to square root of EP square plus EQ square plus 2 EP EQ cos 120. Exactly same as force. There is no change. Only F is replaced by E. That's it. Okay. In MCQ, save your time. Don't write everything. But the same question comes as subjective. You need to write every step. Don't take shortcut there. Don't lose marks like a fool. If you know that you have to write step, you need to write.
Sir, it's 9 into 10 to the power of 3.
Okay, we'll check it. Huh? Huh. We did the same thing. Yeah. Okay, we go to the inquiry and get. Uh-huh. Yeah, it started from 18th May. 18th. It started from 18th March. Okay. So you can come and you can just take the admission form. Yeah, come. Come with me. Suraj, आप अंदर बैठ गए. Actually, one parent has come. They want to take admission for KCET course, which is going on. This is going on. So you can just explain. 18th March. Ah, yeah, Ritvik, close it down. We did draw parallelogram in the forces question. I remember we have drawn force thing here, and I told that resultant will be F itself. And then I told that the forces are equal, so the resultant angle will be 60 degree. Previous question or force the question? Ah, ah. Which question is it? Which question? This one. Or this point? We have drawn the parallelogram. We have done. You didn't copy. For B1, for the B thing we didn't draw, I told that you can copy directly from this. For C also we did draw the parallelogram, you didn't copy the solution. Hmm. But you have used the formula, right? See here, you have not drawn, but which formula you have used? Formula. So resultant का formula you have used. If you are using the resultant का formula, it means what? We are using parallelogram law. Okay? You have not drawn or I have not drawn because maybe I would have told that you draw on your own. Okay? So you are talking about this question, yesterday's problem, where the angle was 60 degree. Correct? Yes. So complete the parallelogram. So this is the resultant. So here this is one vector, this is one vector, the angle is 60. And that's what I can see in your notes also. You have written the resultant ka formula. Okay, so 2 EP EQ. What is our value? Cos 120. So EP and EQ are equal. So I will take that as E. So what will be the answer? E square plus E square, 2E square. 2e square, and cos 120 is minus 1 by 2. So answer is what? Square root of e square, which is e. Now what is e equal to? K q by r square. What is the distance? 0.1. So if you want to find the resultant will be 9 into 10 to the power 9 into charge is 10 to the power minus 8 divided by zero point 0.1 whole square is what? 10 to the power minus 2. So this is 9 into 10 to the power 9 into 10 to the power minus 6, which is 9 into 10 to the power 3. Clear? And what I told that if you're solving a MCQ, don't do this much, because if angle is 120 and both the vectors are equal, resultant will be equal to one of the vector itself, which is E. Written? Okay, next question. So if you practice this question, I think majorly you can cover all points, point on the axis and point which is perpendicular to it, where you have to draw a parallel. Write down the heading, electric field lines. Write down the heading, electric field lines. So due to a positive charge, point positive charge, what is the direction of electric field lines there? Diverge or converge? Diverge. So due to a positive point charge, electric field lines will always diverge. Then due to a positive, not positive, negative point charge, it will converge.
Converge.
It will always converge. Next, have you guys heard of the term dipole? Maybe not in physics, in chemistry. So what is an electric dipole? Two small charges which are equal and opposite, separated by a small distance. So if I take 2 point charges, plus q and minus q, separated by distance. So this is basically a dipole. Now tell me that positive charge, so electric field lines will come towards it or move away? Away. And for negative charge, it will come towards it. So what will be the direction of electric field lines? Starting from here, ending on this. Starting from here, ending on this. Starting from here, ending on negative. Starting from here, ending on negative. All clear? You can draw a few more lines. Is the diagram correct? Any mistake can you guys find out?
Sir, at the minus q,
What is the mistake in minus q?
it should be towards.
Arrow should be towards. Very good. Excellent. Means that you guys are not sleeping. So for negative charge, field lines should be moving towards. You can draw a few more field lines, but this much is enough. Now, if I change the scenario, if I say that both the charge ka polarity is same, Either both of them are plus q or minus q. Will the field lines meet? No. Okay? They cannot intersect in any way. They will never intersect. But what I'm asking that if it is plus q and plus q or minus q, what will be the shape of the field lines? So it will start from here, but will it move towards it? No, because both of them will repel. So field lines will be like this. They will approach each other, but they will repel. They will approach each other, but they will repel. For the negative charge, same thing, but the direction of arrow will be ulta. Right? The direction of arrow will be what? Going away or towards? Towards. That will be the only difference. Make a note of this. You can draw for negative also. One. You can draw a few more lines if you want. Otherwise, this is also perfectly correct. For negative charge, same type of structure. The difference will be the direction of arrow will be towards it. So now let's write down few points. What is the first point? That electric field lines originate from positive and terminate on negative. That's what you can see here. It is originating from plus, terminating on minus. First point. Second point, electric field lines will never intersect. Third point, electric field lines will never form closed loops. These are the three important points which you need to remember. So let's discuss the reason also why electric field lines will never intersect. If you want to write down all the points, you can write down quickly with me. Electric field lines originate from positive charge and terminate on negative charge. Second point, electric field lines will never intersect. Let's understand the reason. Do you guys remember learning this thing in grade 10th? Instead of electric field line, it was just magnetic field lines, right? Exactly same concept. And the reason is also exactly same if you remember the reason. If you take any two electric field lines, this is the first field line, this is the second field line. So what I'm telling that let us assume that they are intersecting. So they are intersecting at point P. So how do you find the direction of electric field line at any point? Draw the tangent. If you want to find the direction of electric field lines at any point, same thing for magnetic field, you draw tangent at that point. I will draw tangent at this point of intersection on line 1 as well as line. If I draw the tangent on line 1 at point P, so where is that line pointing? This direction. If I draw the tangent at this point P for line 2, where is it pointing? So at the point of intersection, how many directions are there? Two. Is it possible for any quantity to have two different directions at same point? Does it make sense? If I tell that you are moving in two different directions at the same point, possible? One leg is going in the left, other leg is going in the right. So the reason here is at the point of intersection, when we draw the tangent to both the lines, it has two different direction with points of intersection, which is not possible. Point of intersection, it should have same direction. Otherwise, it doesn't make sense that they intersect. You can write down the reason. At point of intersection, at point of intersection, electric field lines have two different direction, which is not possible. Therefore, they should never intersect. Therefore, they should never intersect. Electric field lines never forms closed loop. Anyone knows the reason why they don't form closed loop? No one? Let's go back to this figure. See this figure. Here, what is happening? The lines are starting from positive and terminating on. Are they forming a closed? See, closed loop means what? That wherever you are starting, you have to come back. Okay. It means that if this line is starting from plus Q, it has to come to plus Q. Is it possible? It's not possible because if you take a negative charge, it will terminate here. It cannot form closed loop. If you take a positive charge also, will they meet? Because they will repel. So in any case, will it form closed loop? Think logically. Forget about remembering any reason. If you use your common sense from these figures, you can say that here it will terminate on this. Here they will not meet only. Is it possible? Does it seem that they will form closed loop? No. What explanation will you write in the exam? You just give the examples. If it is positive, negative, then it will terminate on negative. It will never come back to plus Q because for forming the closed loop, it has to come back to plus Q. Means it should start from plus Q and terminate also on plus Q. It doesn't, it's not possible. Okay. Same thing you can say if it is plus plus, they will never meet only. If it is minus minus, they will never meet. Clear? They ask the reason in the exam. That's why I'm telling that you should know the reason and should know how to explain it. Any questions before we move to the next topic? We're going to start dipole. No doubts? Write down the heading electric dipole. What is electric dipole? When we have two equal and opposite point charges. Point means small charge. If I have plus Q and minus Q. So we have 2 point charges. This is the center of the dipole, O. Separated by a distance, I am taking 2A. You can take A also. You can take 4A also. That doesn't make any difference. So 2 point charges, which are equal and opposite, separated by a small distance. So this whole system is called electric dipole. So 2 point charges which are equal and opposite separated by a small distance is called electric dipole. So dipole moment is denoted by P. What is dipole moment? charge into distance between them. So dipole moment is vector quantity or scalar? Vector quantity.
Vector.
And what is the direction? Negative to positive. The direction of dipole moment is always from negative to positive. So make a note of this. The direction of dipole moment is from negative to positive charge. Direction of dipole moment will be from negative to positive charge. Means in this case, it will be towards left side. Hmm? In dipole, it's defined. Dipole moment direction is defined from negative to positive. ठीक. So dipole moment का direction will be where? This. Negative to positive. Always. Hmm. What will be the SI unit? See the formula. What will be the SI unit?
Coulomb meter.
Charge is coulomb, distance meter, coulomb meter, coulomb meter. Find the dimensional formula. What will be the dimensional formula? Charge is 80 and this is distance. Distance is what? L. Charge is 80, distance is L. Sure. So this thing is clear to all of you that what is electric dipole, what is the formula, what is the direction, what is the SI unit, and what is the dimensional formula. So we will discuss the first point in this. Electric field due to a dipole at a point on its axis. So electric field due to a dipole at a point on its axis. So let's draw a dipole. So plus Q minus Q, center of the dipole. So this is the axis of the dipole. So I am extending the axis. So I have extended the axis. So this distance is how much? 2a. From the center of the dipole to the point P, I'm taking the distance as r. We take the distance from the center of the dipole. So whenever you are measuring the distance of the dipole from any point, it should be measured from the center, r. I need to find what is the electric field at point P. So can you see that it is basically a numerical what we did just now? This P was which point? Point B. You can check your notes. The previous question. This was 10 to the power minus 8. This was minus of 10 to the power minus 8. And this was point B. It's the same thing. Instead of a numerical, I am asking like electric field due to a dipole at a point on its axis. So what will be the direction of electric field at point P due to positive charge? Towards or away? Away. Electric field due to plus Q. For negative charge, it will be towards the negative charge. So it will be what? E of minus Q. Any problem? So it will be added or subtracted? Subtracted. They are in the opposite direction. So what will I write? EQ minus E of minus Q. Which one will have higher magnitude, EQ or E of minus Q? EQ, because it is closer. Less distance, more magnitude. That's why I did this. Otherwise, you can do ulta. So KQ, what is the distance? Total is R. So what will be this distance? This much. R minus A. Because this much is A, this much is A. This total is R. I want this much. So it will be what? R minus A. So R minus A whole square. Minus. Don't write minus Q again. Because direction we have considered. So KQ divided by, what is the distance of minus Q? R plus A. So let's take common. What can we take common? KQ. So 1 by R minus A whole square minus 1 by R plus A whole square. So take LCM. This is what? A minus B into A plus B. A minus B, A plus B. What is the LCM? A square minus B square. So it will be A square minus B square. And what is outside? Whole square. So when you take LCM in the numerator, we will have what? R plus A whole square minus R minus A whole square. If anyone has problem in calculation, let me know. I'll explain that also. So when you subtract, what will be the answer? A square plus B square will get cancelled. 2AR minus of minus 2AR, 4AR. Is it clear? 2AR minus of minus 2AR, it will be 4AR. So electric field at point P will be KQ into 4AR divided by R square minus A square whole square. All clear? Any problem in the calculation? Now just give me 1 more minute to explain few more things. What is dipole moment? Q into 2A. Here we have what? Q into 4A. Q into 4A will be what? 2 times of dipole moment. 2 times of dipole moment. So this will be K, P, how much P? 2P. So K into 2P. I will give time to copy, understand first. R divided by R square minus A square का whole square. This is the magnitude. Okay? Q into 2A is P, so Q into 4A will be 2P. Now let's understand the direction. See on the board. Just now you guys told that the electric field due to plus Q will be more, right? Because plus Q is closer. Okay? So our answer will be in which direction? Left or right?
Left.
E of plus Q is more, correct? So my final answer will be towards left. Perfectly fine. What is the direction of dipole moment? Left or right? Left. Just now we discussed dipole moment is from minus to plus. So net electric field is in left. Dipole moment is also in left. So direction of electric field and dipole moment in this case is same or different? Same. So what will I write here? P cap. Do you guys know the meaning of cap? I cap. It gives the direction. Cap means unit vector. Unit vector gives the direction. So P cap means this is same as the direction of dipole moment. This is dipole unit vector. It is telling you that boss, the direction of electric field is same as direction of dipole. One last thing. If all of you see on the board, if the point at which you are finding the electric field is very far, the point which you are finding is very far, it means if R is very much greater than A. So can we ignore this A square? So this will become R to the power 4, which will get cancelled. So this will be 2kp by R cube PQ. If R is very much greater than A, we can ignore A square. This becomes R to the power 4. R by R to the power 4 will be R cube. Make a note of this. See the whole working. This derivation comes in your exam. This derivation comes in your exam very regularly. So this year ka paper was exception. No derivation was asked. I think only one for 1 mark or two. It was only numeric physics paper. So things are a bit surprising nowadays. Last year ka paper, ray optics, we all were expecting that more numericals will come because so many numericals were there. And they asked, explain the working of optical fibers, explain the working of telescope. Okay. So nowadays it's very difficult to predict. You can't predict. Anything is possible. So sometimes we study so many numericals and we start thinking numerical will come, and we start ignoring theory. You have to balance both. Okay, I'm not telling that you start reading theory very frequently. Frequently you solve problem. Once in a while, read the theory also. Copy it. All clear? No doubts? Very good. Now write down the heading. Electric field due to a dipole. Electric field due to a dipole on equatorial on a equatorial point. Now let's understand what is the meaning of equatorial point first of all. All of you have heard about perpendicular bisector. So if my palm, if you see my palm, this is horizontal plane or vertical? Horizontal. Assume that, I hope that all of you can see. Huh? So the dipole is on the palm. If this pen is the dipole. So if I extend this, we get which point? Axial point. So axial point is in the plane of dipole. Equatorial point means if I make one more plane here. So this AC ka remote is which plane? Perpendicular to the plane of my palm or dipole. So the plane which is perpendicular to the plane of dipole is called equatorial plane. And the point on that plane is called equatorial point. Is the Honda clear? Okay. So equatorial plane means a plane perpendicular to the plane of dipole. So don't get confused after seeing this word. Yeah, I know that's a new word for you. Equatorial plane means a plane perpendicular to the plane of dipole. So let's derive it. The same figure we will draw. Plus q minus q separated by distance 2a. This is the center. I will take a point which is perpendicular to this. Let's take a point which is perpendicular to this. So this is the point P. So this is the point P which is perpendicular to the plane of dipole. So this is the plane of the dipole perpendicular to the plane of dipole. So I will take a point P here. Any problem in drawing the figure? So we take the distance of the point P from where? From the center of the dipole. That's what we discussed in the last one. So from the center of the dipole to the point P, what should be the distance? R. This distance will be how much? A. This will be also A. So what will be this distance? Square root of R square plus A square. Same thing, this distance will be square root of R square plus A square. Learn that how I'm drawing the figure. Don't try to mug up the figure. See the steps, how the figure is drawn. First dipole, a point perpendicular to the dipole, then join this. By Pythagoras theorem, we found the distance. If I take this angle as theta, this angle should be also how much? Theta. Because all the dimensions are same. Now, due to positive charge, the electric field lines will be away. So now you will see this figure is same as the point C. Previous question, the numerical what we have solved. So in the numerical, the point C, it is exactly same case. Correct? Previous case was same as point B. This case is same as point C. So for positive charge, away. For negative charge, towards. So what will be the resultant? Draw the parallelogram. Complete the parallelogram. So this is the resultant. Now you will say, ki, sir, we can apply the parallelogram law, but we don't know the value of theta. How will I solve? You know the value of theta? No. So here, rather than applying parallelogram law, I will take the components. So just answer one simple thing. If this is theta, what will be this angle? Theta.
Theta.
Alternate interior angle. If this is theta, what will be this angle? Theta. Which angle? Corresponding angles. Well, if you know, remember corresponding alternate. So it is basically what? This line and this line are parallel to each other. If this is theta, this should be theta. This line and base are parallel. If this is theta, this will be theta alternate. Just see on the board. 1 minute, I will explain everything. Then you can copy aram se. First understand. So this is the electric field due to plus Q. This is the electric field due to minus Q. If you take the component, this will be cos component. This will be also cos. So ER will be equal to how much? EQ cos theta plus E of minus Q cos theta. Okay. Now tell me the magnitude of EQ and E of minus Q is same or different? Same. Because distance is same, charge is same. So what can I write this as? 2 times of EQ cos theta. All clear? Now, last thing. What is the direction of ER? Towards right. What is the direction of dipole moment? Left. Dipole moment is from negative to positive charge. So dipole moment will be towards left. Electric field is towards right. So what will be the direction? Minus P cap or plus P cap? Minus P cap. So make a note of these things. Why minus P cap? Dipole moment is from negative to positive. ER is towards right. Now let's substitute things. So what is the electric field due to this? KQ by R square. What is the distance? This much. So KQ by square root of R square plus A square, a whole square. See on the board, stop writing, you'll get enough time to copy. See this triangle. What will be cos theta? Cos theta is base by hypotenuse. Cos theta will be base by hypotenuse. So base is how much? A divided by . So let's simplify this. It is solved now. Just will take 30 more seconds. So KQA. What we will get in the denominator? This is power 1 by 2. And what is this power? 1. Square root and square gets cancelled. So 1 plus 1 by 2, 3 by 2. 1 plus 1 by 2, 3 by 2. This is the value. Now we'll apply the approximation in this. What approximation? If the point is very far, if the point is very far, what will be ignored? A square. Correct. So if point is very far, A square will be ignored. Don't ignore this A also. Okay, because we are comparing A with R. Comparison is happening here. Don't ignore this A also. So 2KQA. So here A square ignored. So this becomes what? R square to the power 3 by 2. 2 gets cancelled. So what will be the thing? R cube. Now just notice one thing. All of you check your notes. What is the formula for dipole moment? Q into 2A. So this becomes what? Q into 2A. Kp by R cube minus P. If you notice few things, just 2 points. Last 1 minute. The dipole moment ka magnitude for the axial point was 2 Kp by R cube. You can check your notes. At axial point, it is 2 Kp by R cube. At equatorial point, it is Kp by R. This is the first relation. That the dipole moment, right? So electric field due to a dipole on an axial point is 2 times equatorial. First difference. Second, direction is opposite. So make a note of this. Do practice the derivation. Derivations are important. Is it? Anything else? Any student want to clarify on any point regarding direction, taking components, angle? So you can write down electric field on axial point is basically 2 times the electric field on equatorial point. And the direction is also opposite. Make a note of that. Now, the last thing which you need to notice here is the electric field due to a point charge depends upon the distance. By which relation? Inversely proportional to r square. Inversely proportional to r square. Here, if you notice, it is inversely proportional to r square or r cube. R cube. Okay, this is also a point which you need to notice. Electric field due to a point charge is kq by r square. So that depends on 1 by r whole square. Here, it depends 1 by r cube. So make a note of that. The electric field due to a dipole depends upon the position as inversely proportional to r cube. As inversely proportional to r cube. See here, no? Inversely proportional to r cube. This is the electric field due to what? Dipole. But for a point charge, it was kq by r square. For point charge, it depends upon 1 by r square. Here, due to dipole, it depends on 1 by r. Done? All clear? Write down the heading. Or on a dipole in a uniform electric field. Torque on a dipole in a uniform electric field. All of you remember what is torque? R cross F. Or you can say torque is a force which is responsible for rotating the system. Rotating force. So let's draw a dipole here. Plus Q minus Q. All of you draw the figure. Plus Q minus Q. It is present in a uniform electric field. Uniform electric field. Uniform means the strength is same at all the points and the direction is not changing. That is the meaning of uniform. So uniform electric field lines means the direction and the magnitude is not changing with time and position. So this dipole is inclined with respect to electric field lines and it is forming an angle theta. It is forming an angle theta. And this distance is how much? 2a. Correct? So if that distance is 2a, what will be this much distance? If this is 2a, this is theta. What will be this much distance? 2a sine theta. Basic trigonometry. Correct? Is the figure clear? Uniform electric field, inclined dipole at angle theta. The distance is 2a, so this distance will be 2a sine theta. So tell me that will this electric field apply a force on this? Yes. What is the force? QE due to electric field. So charge is positive. Force will be in the same direction of electric field. So where will be the force on this? QE. On this negative, where will be the force? Opposite to electric field. So force will be here minus QE. I'm not writing minus because direction is opposite. Is it clear? I'm not writing minus because I already did the direction ulta. So what is torque ka definition? Force multiplied by distance. Or you can say R cross F. Or what we say, force multiplied by perpendicular distance. Listen to the statement. Force multiplied by perpendicular distance. Force multiplied by perpendicular distance. So what is the force? QE. And what is the perpendicular distance? 2a sine theta. Make a note of the definition of torque. Force multiplied by perpendicular distance. Now, all of you see on the board, stop writing. See on the board. Just rearrange the term. I'm rearranging the term. See how. So Q into 2a into E into sine theta. What is Q into 2a? Dipole moment.
Dipole.
So if I write in the form of vector, this is dipole moment. This is E. What is AB sine theta? A cross B. Cross product. AB sine theta is A cross B. So this will become P cross B. This is the final expression. Any problem? I'm explaining again. This is dipole moment. So this is P E sine theta. AB sine theta is same as A cross B. So make a note of this. This is the last topic. So in your exam tomorrow till here questions will be asked. Take it till here. When will this torque be maximum? When sine theta is maximum. So when is sine theta maximum? 90 degree. When this torque be minimum? When sine theta is 0. Sine theta is 0 for which angles? 0 as well as 180. So if dipole moment and E are parallel or anti-parallel, it will be minimum. If dipole moment and electric field are perpendicular, then torque will be maximum. So make a note of this. Now on this note, we will wrap up the physics class. Everything. Start the math class in 5 minutes.